Hi, I'm Hussein, and welcome to episode 4 of the Grasshopper from Zero series. If you've watched the previous episodes, in the first 3 parts, we got familiar with the Grasshopper interface, its components, and the overall logic of how it works. But today, we're stepping into one of the most important, and at the same time, one of the most challenging concepts in Grasshopper. A concept that, if you truly understand it, will instantly take your work to a much more professional level. And if you don't, you'll probably find yourself saying this again and again. Why did my output turn out like this? Today's topic is data trees, something that can honestly be called the beating heart of Grasshopper. Let's start with a real-world example. Imagine you're designing a building facade with around 1,200 panels, but not repetitive panels. Each one has its own size, its own rotation, and even a different response to light or view. Now, the real question is, how do you control all this data at the same time? How do you make sure that each panel receives exactly its own information and not someone else's? This is where data trees come into play. Contrary to what many people think, Grasshopper doesn't work only with simple lists. Instead, it works with layered data structures, exactly like a tree, with branches, sub-branches, and each branch holding its own specific data. If you've ever seen a component produce a strange output, or your data gets mixed up, or everything suddenly collapses into a single result instead of staying separated, you can be almost sure that the problem wasn't the component itself, but your understanding of data trees. In this video, step by step, and in a very simple way, we're going to understand what a data tree actually is, how it's different from a normal list, and how controlling data trees helps us create precise, professional outputs. Don't worry, there are no complex formulas here, and no boring theoretical explanations. Everything will be explained using real examples inside Grasshopper, in a way that after this video, when you hear the term data tree, you won't want to run away anymore. So if you want to truly understand Grasshopper, not just memorize it, make sure to stay with me until the end. All right, let's get started. Before we dive into the details of data trees, there's one very important difference that we need to make completely clear first. The difference between a list and a tree. Many of the problems people face in Grasshopper start exactly right here. So, what is a list? A list is the simplest data structure we have. You can imagine it like a line of soldiers standing in a row, all next to each other, all on the same level, with no grouping and no layering. For example, a few points on a line. Grasshopper sees them as a list, point 1, point 2, point 3, and so on. It doesn't matter where they were created or what they belong to. They all live inside a single collection. Lists are great for simple tasks, but the moment your project becomes even slightly more complex, this is where a list starts to fall apart. So, what is a tree? Now we arrive at the idea of a data tree. A tree, exactly as the name suggests, has a multi-layered structure. Just like a real tree, it has a main trunk, multiple branches, and each branch can have its own smaller branches or leaves. This structure allows us to organize our data into groups, perform operations on each subset independently, and manage complex projects without everything falling into chaos. This is the point where Grasshopper really starts to show its true power. Branch and path. Now let's be a bit more precise. What is a branch? Each branch is essentially a subset of data. You can think of a branch as a single branch of the tree. Each branch holds its own specific data and is considered independent from the other branches. For example, each row of panels, each floor of a building, or each repeating module can exist as its own separate branch. So, what is a path? A path is the address of a branch. Think of it like a GPS location when Grasshopper shows something like 0, 1, 2. It means start from the main trunk, go to branch 0, then to sub-branch 1, and then to sub-branch 2. Each number represents one level of the tree, and the deeper the path is, the more layers your data has. Multi-level data structures, one of the most powerful features of data trees is exactly this, their multi-level nature. Data can exist on a single level or across multiple layers of depth. To make this more tangible, let's look at a real-world example. Imagine level 1, urban blocks, level 2, buildings inside each block, level 3, windows of each building. If you try to handle this using simple lists, everything gets mixed together. But with a data tree, each window knows exactly which building it belongs to and which block it comes from. This is precisely what makes Grasshopper so powerful for parametric design. How do we see a data tree? Now comes a very important question. How can we tell whether our data is a list or a tree? And more importantly, what does its structure actually look like? This is where a few very powerful tools come in. Data Viewer or Panel. The panel, or data viewer, is mostly used to see raw data, numbers, points, or any other kind of output. But keep this in mind, the panel simplifies everything. And it doesn't always reveal the real depth of a data tree. So don't rely on the panel alone. Param Viewer. The Param Viewer helps us see the paths, understand how many branches we have, and understand the overall structure of the data tree. If you truly want to understand data trees, this tool will become one of your best friends. Now it's time to move on to the most important tools we use to control data trees in Grasshopper. If you understand these components correctly, about 90% of your data tree problems will disappear. Graft. The first, and probably the most commonly used component, is Graft. So, what does Graft actually do? Graft creates a separate branch for each item. Instead of keeping all the data inside a single branch, each item gets its own individual path. Let's look at a simple example. Imagine we have this list A, B, C. Before Graft, all of these items live inside one branch. 0 goes to A, B, C. But what happens after Graft? Each item moves into its own branch. 0 and 0 goes to A, 0 and 1 goes to B. 0 and 2 goes to C. So our data structure changes from a simple list into a real data tree. When to use Graft? Whenever you want to apply individual scaling, individual movement, individual rotation to each item, Graft is usually the first thing you should think about. Now, the exact opposite of Graft, Flatten. So, what does Flatten do? Flatten removes all branches and pours all the data into a single branch. In other words, it turns a tree into one flat list. For example, imagine this tree. 0 and 0 goes to A, 0 and 1 goes to B, 1 and 0 goes to C. After Flatten, everything becomes A, B, C, no branches, no paths, no layers. One important note, Flatten is extremely powerful. But if you use it without a clear reason, it can completely destroy the logical structure of your project. So always ask yourself, do I really want everything to become one? The next component is Simplify. So, what does Simplify do? Simplify cleans up and shortens the structure of a data tree. It removes unnecessary branches and redundant paths. without deleting any data. For example, 0 and 0 and 0 goes to A. 0 and 0 and 1 goes to B. After simplify, 0 and 0 goes to A. 0 and 1 goes to B. The data stays exactly the same, but the paths become cleaner, more logical, and easier to read. Simplify is a great choice when your tree has become too deep, your paths are unnecessarily long, or your outputs are hard to read. Now, let's talk about trim tree. Trim tree isn't designed to selectively remove a specific branch. Instead, it's used to shorten the structure of a data tree to a specified path. What does that mean? It means trim tree removes all branches that are deeper than the given path, keeping the tree structure only up to that level. Trim tree is mainly used to control the depth of a tree and simplify its data structure, not to remove a specific branch. It's particularly useful when the tree has become very deep and complex. You want to reduce the level of detail, or you need to clean up and make the data structure manageable before continuing the process. And finally, we arrive at one of the most important analytical tools in Grasshopper: tree statistics. Tree statistics is used to analyze the complete structure of a data tree. This component doesn't change the data itself, it only provides statistical and structural information about the tree. With tree statistics, we can find out how many branches exist, the total number of items, the depth of the paths, and exactly which paths are present in the tree. Tree statistics is especially useful when you're working with complex data trees. You're not exactly sure what your data structure looks like, or when you want to understand the tree before modifying or manipulating it. All right, in this video, we explored one of the most important concepts in Grasshopper: data trees. We saw the exact difference between a list and a tree, how branches and paths define the structure of your data, and how using tools like Graft, Flatten, Simplify, Trim Tree, Tree Branch, and Tree Statistics, we can control our data instead of letting the data control us. If there's one key takeaway from this video, let it be this: Grasshopper isn't just about designing forms, it's about managing data. The better you understand data trees, the more precise, clean, and professional your outputs will be. If you found this video helpful, make sure to like it and subscribe to the channel so you don't miss the next episodes in this series. In the upcoming videos, we'll dive into more practical examples and projects that show exactly how data trees are used in real-world parametric design. If you have any questions or doubts, drop them in the comments. I'll read and reply to them myself. Thank you for sticking with me this far until the next video. Take care.